Hey guys, let's have a look at the following question. Now here, the part one asks a time t0 switch is moved to position. Okay, they're asking us to calculate the time at what time the current through R is equivalent to 1 by K times the initial value. Now let's start answering A part 1 to begin with. A part 1. Now, we know that current I at any given time t in an RC circuit is given by the formula I of t equals I naught, which is the maximum value of current, into e to the power of minus t by tau. Here, I naught, the maximum value of current, is nothing but the input EMF epsilon divided by total resistance. The resistors small r and capital R are in series in this given possible connection. So total resistance is just R plus R. And tau is just total resistance R times C, which here is small r plus capital R times C. That's it. Now, they say that at time t equal to 0, when switch is moved to position 1, at what time instant is the current to the resistor R equal to 1K times the initial value. So the current I must be equal to 1 by K times the initial value. So which means I need to equate this with the substitutions given here, these two. I need to equate epsilon divided by small r plus capital R multiplied by e to the power minus t by small r plus capital R times c equal to 1 by k times epsilon divided by small r plus capital R. Simplifying this, I get the equation as T is equal to ln of k times small r plus capital R into C. Moving on to part 2, they're asking at what time is the charge equal to 1 by k times 1 by k times the maximum value. Charge has the exact same formula. I is I naught e power minus t by tau. Q is Q naught e power minus t by tau. Q naught is just, remember, capacitor. So Q is just C into V. Here it is just epsilon. So the same equation can be found out, except instead of I naught, we write Q naught as C into epsilon naught, and total resistance still remains R plus R. So you get the value as T is equal to ln K divided by K minus 1 times small r plus capital R times C. Moving on to part 3. They are asking at what time is the energy stored in the capacitor equal to 1 by K times the maximum value. So we know that energy or potential energy stored can be written by a formula U is equal to Q square divided by 2C. So with substitutions, we can write Q of T the whole square, which is what we wrote in the previous part, divided by 2C is equivalent to 1 by K times the maximum value. Maximum value of charge is C epsilon naught, as discussed in the previous part, Q square divided by 2C. 2C gets cancelled. Q of T is an exponential equation given by Q of T is equal to, it's the same equation we wrote before, Q naught e to the power minus T by tau. It's the same equation we wrote in part 2. Substitute it here, simplify, cancel 2C on both sides. We end up with the equation T is equal to ln square root of K divided by square root of K minus 1 times R plus R into C. Moving on to part D, subsection 1 or part 1 again. Now, this switch has been moved from position, has been in position 1 a long time. It is moved to position 2. Now, when it is moved from position 1 to 2, remember, these, the EMF and R have no significance here. The capacitor acts as secondary battery, although not an infinite source, a degrading secondary source of battery, allowing current to pass through R until the entire energy stored in the capacitor has been exhausted. This is basically a capacitor discharging. Now, the same formula applies for this as well. They're asking us at what value will the current be this. So just remember, current is given by the formula I is equal to I naught e power minus t by RC. So equating I naught e power minus t divided by RC or tau equivalent to 1 by k times I naught. I get the value of t to be t is equal to ln k times RC. Let me write this better. Ln k times RC. Moving on to part 2. The last part, they're asking at what time is the charge equal to 1 by k times the initial value. Use the exact same constant. You end up with the equation. Please use the exact same equation, not the constant. You end up with t is equal to ln of k times RC. So this is the final answer to our question. Thank you.